Good evening, sir. This is Sai Pranita, and I am here to present a video on bipolar junction transistors. Introduction to bipolar junction transistors. Bipolar junction transistors are semiconductor devices used for amplification and switching. They consist of three layers of semiconductor materials forming two PN junctions. BJTs are classified into two main types, NPN and PNP transistors. Structure of BJT. A BJT has three regions: emitter, base and collector. The emitter is highly doped to inject charge carriers into the base. The base is lightly doped and thin, allowing for efficient carrier transport. Operating principles. BJT operate by controlling the current flow through the base emitter junction. When a small current flows into the base, it allows a large current to flow from the collector to the base. This principle of operation enables BJT to function as amplifiers and switches. Configurations of BJT. A transistor has three terminals. Any of these three terminals could be connected to form the common input and output terminal. Depending upon the terminal which is used as a common terminal, there are three types of transistor configurations. Number 1. Common base configuration, which is also known as CB configuration. 2. Common emitter configuration, which is also known as CE configuration. 3. Common collector configuration, which is also known as CC configuration. Common base configuration. In this type of configuration, the base terminal of the transistor serves as a common terminal, so it is called as common base configuration. The input voltage is applied between base and emitter terminal. The output is taken between collector and base terminal of the device. Common base configuration has low input resistance but a high output resistance. Current gain in common base configuration is denoted by Greek letter alpha. It is defined as the ratio of collector current to the emitter current. Mathematically, it is represented as collector current divided by emitter current. Common emitter configuration. This type of configuration is called as common emitter configuration, as the emitter terminal of the transistor is made as a common terminal. The input voltage is applied between base and emitter terminal of the transistor. The output is obtained between emitter and collector terminal. Common emitter configuration has a low input resistance but very high output resistance. Current gain in common emitter configuration is denoted by a Greek letter beta. It is defined as the ratio of collector current to the base current. Mathematically, it is represented as collector current divided by base current. Common collector configuration. Common collector configuration, as the collector terminal of the transistor is made as common terminal. The input voltage is applied between base and collector terminal of the transistor. The output is obtained between emitter and collector terminal of the transistor. Common collector terminal has a very high input resistance but a low output resistance. Current gain in common collector configuration is denoted by Greek letter gamma. It is defined as the ratio of emitter current to the base current. NPN versus PNP transistors. NPN transistors have electrons as the primary charge carriers, while PNP transistors use holes. In an NPN transistor, the current flows from the collector to the emitter, while in PNP, it flows in the opposite direction. Both types can be used in various electronic circuits depending on the required functionality. Current voltage characteristics. The output characteristics of BJT are defined by its collector current versus collector emitter voltage. The transistor operates in three regions: cutoff, active, and saturation. Understanding these regions is crucial for designing circuits that utilize BJT effectively. BJT as an amplifier. BJT are frequently used in analog circuits for signal amplification. The small input current at the base controls a much larger output current at the collector. This property makes BJT essential components in audio and radio frequency applications. BJT as a switch. BJT can also function as a electronic switches in digital circuits. By applying sufficient base current, the transistors can be driven into saturation for on state. When the base current is removed, the transistor enters cutoff, effectively turning it off. BJT biasing techniques. Proper biasing is necessary to ensure BJTs operate in desired region. Common biasing methods include fixed bias, collector feedback bias, and voltage divider bias. Each method has its advantages and is chosen based on the specific application requirements. Limitations of BJT. BJT have slower switching speeds compared to field effect transistors. They are also more sensitive to temperature changes, which can affect performance. Understanding these limitations is important for selecting the right transistor for a given application. Applications of BJT. BJTs are widely used in audio amplifiers, radio transmitters, and receivers. They also play a crucial role in digital logic circuits and power control applications. The versatility of BJTs makes them fundamental components in modern electronics. This presentation provides an overview of bipolar junction transistors while covering their structure, operation, characteristics, and applications. Thank you.